Today we'll be discussing surds. What are surds? Surd is simply the root of the rational number, like 2, 3, 5. What is a rational number? A rational number is a number that is in form of a fraction or a normal number like 1, 2, 3, 4, 5, and so on. So while surd is the root of a rational number, meaning surd is the root of a rational number that doesn't have a square root. For example, when we say square root of 4, we have 2. You know square root of 4 is not a surd. You understand? Surd itself are irrational numbers. So you can't have a surd that is a rational number. So square root of 4 is 2. So it means square root of 4 is not a surd. Square root of 16 is what? 4. It means square root of 16 is not a surd. Meanwhile, square root of 2 is what? We don't know it. Square root of 2 is what? Square root of 2. Also, square root of 3 is what? Square root of 3. Also, square root of 5 is what? Square root of 5. When we press this on calculator, it just continues to give us long numbers. So, these are surd. They don't have square roots. Surd expressions are simplified by first factorizing the number inside the root sign, where it is factorizable. So to simplify a surd expression, we need to simplify the number inside the square root, inside the root sign, if that number is factorizable. For example, let's say for example, we want to work on square root of 8. Square root of 8, for example. So what are we going to do? First thing is to check if the square root of 8 is factorizable. Abi? And from here, if we say that if A and B are real positive numbers, then square root of A, when we have square root of A, B, everything is square roots. It's same thing as having what? The root of A times the root of B. You understand? Or if you have it in this form, square root of A over square root of B, the same thing as having what? Square root of A alone over square root of B. Do you understand? So let's take this for an example. Square root of 8. So the first thing we'll try to do is factorize what's inside the root. Yeah, right? So when we look at 8, what are two numbers that we can multiply together in which one of them will give us a square root? When we find the square root of one of the numbers, we have a real number or a rational number. Think. So we have 4. 4 can go in 8 how many times? 2. Right? So, and square root of 4 is what? 2. So that means we can get square root for 4. So our answer is what? 4 times 2. 4 times 2. Right? So we are trying to factorize this. So this is the same thing as having what? Square root of 4 times square root of 2. Right? Square root of 4 times square root of 2. What's square root of 4? 2. What's square root of 2? You know, that's not possible, right? So square root of 2 is what? Root 2. This is 2 root 2. So square root of 8 is the same thing as what? 2 root 2. You can point your calculator to confirm this. I'm sure it's going to give us the same. So let's take one more example. So square root of 45. So let's think. What are two numbers we can multiply together in which one of them will give us as a real number as its root? Let's think. So 9. Let's think of let's look at 9. Let's look at 9. 9 can go in 45. How many times? 5 times, right? So this is 9 times 5. So this is same thing as having what? Square root of 9 times square root of 5, right? What's square root of 9? 3. Square root of 5 is simply 5, root 5. So this is same thing as having 3 root 5. Surds. Addition and subtraction of surd. So 2 surds or more. 2 surd or more. Because we can have 3 surd that we want to add together. Can be added together or subtracted together or subtracted from each other when they have the same root. When they have the same root. So, but if the root are not the same, we can't do the addition or subtraction. We can't. So when they have the same root, let's say for example, 4 root 2 plus 3 root 3. These two, this for this, we can't do addition and subtraction. We can't add them together. So we can neither do addition for this or do subtraction for this. So let's take a real example. So 4 root 2 plus 6 root 2. You can see it is possible in this scenario, right? So what are we going to do? These whole numbers, we are going to add them together. 4 plus 6 is what? 10. And then the next thing is going to be what? We'll take one of the bases. That's 10 root 2. We'll take one of the surds, and the answer will be 10 root 2. Do you understand? Do you understand? Let's take another example. 3 root 5 minus 7 root 5. Here, what are we going to have? So like we did in the other place, in here, we are going to take the whole numbers. That's 3 minus 7. 3 minus 7 is what? Minus 4. Then we are going to take one of the surds, right? That's root 5. Do you understand? Do you understand? Let's continue. Let's take another example. 3 root 8 plus the square root of 50. In this scenario, what are we going to do? The first thing we are going to do in this scenario is let's look at this and this. They can still be factorized, right? Yes. So you can do this. 3 open brackets. Square root of root 8 is same thing as having what? 4 times 2. Right? Then plus root 50 is same thing as having what? 25 times 2. So in this scenario, you see, normally, on a normal scenario, these roots are not the same. But we see that they can still be factorized. So let's check whether if you factorize them, maybe we'll come towards both of them having the same roots. Let's see if you can achieve that. So 3 open bracket, square root of 4 times square root of 2 plus square root of 25 times square root of 2. Right? So this is same thing as having what? 3. Square root of 4 is what? 2. Root 2. Right? Then square root of 25 is what? 5. So I brought the 2 out. You understand? So this is 25. Square root of 25 is what? 5. Is 5 root 2. So 3 times 2 is what? 6. 6 root 2 plus 5 root 2. Right? 6 plus 5 is what? 11 root 2. 11 root 2. That's our answer. You can try and do this with your calculator. You're surely going to get this. To multiplication of surds. So when two or more surds are multiplied together, they should first be simplified, if possible. Then the whole number will be multiplied with the whole number, and the surd will be multiplied with the surd. Do you understand? So let's illustrate this with an example. Square root of 27 times square root of 50. How do we solve this? How do we solve this? The first thing we need to look at is, can we simplify this? Each of them? What's the answer? Yes. You all know we can simplify this. If you have watched the video this far, you know you can simplify this. So 27 divided by 9 should give us 3, right? So this is same thing as what? Having 3 times 9 times, this is same thing as having what? 2 times 25, right? To cut the long story short, this is same thing as having what? 3 root 3 times 5 root 2, right? So this is same thing as having 3 root 3 times 5 root 2, right? So at this stage, we will now follow our rule. What does it say? The whole number will be multiplied with the whole number, and the surd will be multiplied with the surd. Do you understand? So meaning, we are going to take this whole number, this 3, and this 5. So 3 times 5 is what? 15. Right? 3 times 5 is 15. Then the surd will multiply with the surd, right? 3 times 2 is what? 6. So put the roots. 15 root 6. 15 root 6. Do you understand? Do you understand? When you try this on your calculator, you see this, the answer is going to give us. Fifteen root 6. Question number 2. Square root of 2 times square root of 6 times square root of 3. When we check these 3 numbers, you can see that we can't factorize them any longer, each of them. So what do? In this case, we just multiply them with each other directly. So 2 times 6 times 3, that will give us what? 36. So this is the same thing as having what? Square root of 36. And we all know square root of 36 is what? 6. Do you understand? Do you understand? Yeah. Let's move on to the next question. Square root of 5 times square root of 24 times square root of 30. So when we check this, although this cannot be simplified, let's check for this one. Can this be factorized further? Do you think it can be factorized? I don't think so. Let's 24 divided by 4 is what? 6. Yes, you can factorize. So 4 times 6 is what? 24. What about this? Can it be factorized further? Let's think. So 30 divided by 10 will give us 3. I don't think it can be factorized because 10 doesn't have a square root. So this center will be what? Root 5 times square root of 4 times 6 times what? Square root of 30. Right? Square root of 5 times this center in a nutshell, this center will be what? 2 root 6, right? Times square root of 30. So let's multiply the whole numbers first. Then we have 2. Multiplying the whole numbers, we have 2, right? Then the surds. 5 times 6 times 30. That's what? 900. So this same thing as having what? 2. What's square root of 900? 30. The same thing as having what? 2 times 30 is equals to what? 60. I hope you understand. So you can see it's as simple as ABC. It's very simple. Let's move on to the division of sorts. So question number 1. Let me take the first question and I will explain the jargons. Six root 3. 6 over root 3. 6 over root 3. Yeah. So division of surd. If a fraction has a surd as a denominator, if a fraction has a surd as a denominator, like this one, this has a surd as a denominator. This is a numerator, this is a denominator. This is a numerator, this is a denominator. Right? So if a fraction has a surd as denominator, like this, it is best to rationalize the denominator. It is best to do what? To rationalize the denominator. To rationalize the denominator, it means to make the denominator into a rational number. So, for example, the denominator in this stage is an irrational number because it's a surd. So, our goal is to do what? Is to make this denominator a rational number. So, to do this, you multiply both the numerator and the denominator by a surd that makes the denominator rational. Right? By a surd that makes the denominator rational. So that's what we'll do. So we'll multiply both the numerator and the denominator by a surd that makes the denominator rational. So what's that surd in this instance? It's root 3. Because it's only root 3 that can make this rational. So we'll do this. We'll multiply the numerator and the denominator by a surd that makes the denominator rational. Right? Right? So in this scenario, what are we going to do? This same thing having what? 6 root 3. Root 3 times root 3 is what? 3. Right? So this goes here twice. So this same thing having what? 2 root 3. Do you understand? Let's move on to the next question. 5 over root 5. In this scenario, what are we going to do? The same thing. Multiply the numerator and the denominator by a fraction that will make the denominator rational, right? So the same thing as having what? 5 root 5 all over root 5 times root 5 is what? 5, right? The same thing as having what? Root 5. Let's take one more. Root 18 over root 2. The goal is to make the what? The denominator rational. So this ends as what? 18 over root 2 times root 2 over root 2, right? So root 18 times 2 is what? 18 times 2 is 36. So this is root 36 all over root 2 times root 2 is equals to 2, right? Square root of 36 is what? 6. This is 6 over 2. This gives us what? 3. Question number 4. This question number 4 is a bit more complex than the ones we'll be doing. So this is root 3 times root 18 times root 39 divided by root 24 times root 26. To solve this, root 3 times this same thing as having what? 3 times 9, right? Times, I said 3 times 9, 3 times 6. This same thing having what? 3 times 6. We should go this one. Let me just refresh. This one. Question number 4. Square root of 3 times square root of 18 times square root of 39 divided by square root of 24 times square root of 26. Square root of 3 times 2 times 9, 18, right? 2 times 9, square root of 2 times 9 times, simplifying this will give us what? It still give us square root of 39, because I don't know anything that can go in 39. So for this, square root of 24 is the same thing as what? 4 times 6 times the square root of 26, but I don't know anything that can go in 26. So this is the same thing as having square root of 3 times 3 root 2 times square root of 39, everything divided by 2 root 6 times square root of 26, right? So we can, at this stage, we can decide to either multiply everything together, so try and multiply everything together, or we can try and do some divisions at this stage. So let's take this. So you can see with 3 times 3 with 2 will give us what? 3 with 6 times with 39. Everything divided by 2 with 6, right? Times square root of 26. So with 6 cancel with 6, right? So this is the same thing as us having what? 3 with 39 all over 2 with 26, right? So this is the same thing as us having what? 3 over 2 square root of what? 39 over 26. This is the same thing as us having what? 3 over 2 square root of 39 over 26 will give us what? So as well having square root of what? 3 over 2 square root of what? 3 over 2. Right? This is still now the same thing as well having what? 3 with 3 over 2 with 2. Abi, according to our law that A over B is still the same thing as what? Square root of A over what? Square root of B, and vice versa. So we did this, we used this here. So it was in this form here. Then we transformed it to this. Then is this at this stage, it was this form, then we transformed it to this. Right? So at this stage, what we need to do is what? Rationalization. Rationalization. So 3 root 3 over 2 root 2 times root 2 over root 2. So this is the same thing as also having what? Root 3 times root 2 is what? 6. Root 6. Because 3 times 2 is simply 6. Then 2 times root 2 times root 2. Root 2 times root 2 will give us what? 2. Then 2 times 2 is what? 4. So this is okay. 3 root 6 over 4. That's our answer. So this is the same thing as having what? 3 over 4 with 6. I hope you understand. Question number 5. Two root 2 minus 3 all over root 2 plus 4 all over root 8. So how do you solve this? How do we solve this? There are a lot of ways we can solve this. A lot of ways we can solve this. But I think the easiest of them is to simply look for the LCM. So root 2 times root 8, this gives us what? Root 16, which is the same thing as what? 4. Right? Root 16 is 4. Right? So 4 here goes once. And this will give us what? 8 root 2. Right? So 4 here. Remember this, this means 4 here will give us what? Root 8 minus 3 root 8 plus 4. 4 here will give us what? Root 2 plus 4 root 2. Right? So this is same thing as us having 8 root 2. Let's try and factorize this. So when we factorize this, we know we'll be having what? 2 root 2. right? This is same thing as having 2 root 2, because this is 2 times 4, right? 2 times 4, then you arrive at 2 root 2 plus 4 root 2, everything divided by 4, right? 8 root 2 minus 6 root 2 plus 4 root 2 is all over 4. 8 minus 6 is what? 2. 2 plus 4, 6. So this is same thing as what having 6 root 2 all over 4, right? This goes here once, this goes here. So this is same thing as having what? 3 root 2 all over 2. Do you understand? Do you understand?